we learned that the center of rotation does not change. So if a vertex of your polygon is the center of rotation, it will not rotate. We also learned that counterclockwise means the direction opposite of that of a clock, and clockwise means the direction of a clock. Okay? Each quadrant, there are 4 quadrants in the coordinate planes below, is 90 degrees, and so one turn for one quadrant is 90 degrees. The problem states, triangle XYZ has vertices x, 3, -1, y, which is 5, -4, and z, 1, -5. Graph triangle XYZ and its image after each rotation. Then give the coordinates of the vertices for triangle x prime, y prime, z prime. So the first thing we're going to do for number 1 is actually graph XYZ. So x will be over at 3, down at 1. Oh. So here we go. I'll get it up in just a second. Okay, so here's point x. Y is over 5 and down 4. So there's point y. And z is over 1 and down 5. So there is point z. So what we're going to do is we are going to connect these with line segments to create the triangle XYZ. Next, what you may notice is that we have the instructions to go 270 degrees counterclockwise, so that's in this direction, about vertex x. Vertex x is right here. That will not change, so x prime will actually be equal to x in this case. So we can actually just write that. So the thing that I like to do when rotating about a point is create my own 4 quadrants. I'll do that in green. So I go straight horizontal through the point as well as straight vertical through the point. And now I have my new set of 4 quadrants. So now what I can do is look at the relationship between y and those new green axes. If I look at y, it seems to be 3 spaces away from that horizontal axis going through the center of rotation. Here at this point, we're going to call that a star y. We don't really need to, I just like to. And if we're rotating 270 degrees from there, I'm going to go here, and then here. So there's that star point again. But y was 3 spaces behind it in our rotation. So I'm going to go 1, 2, 3 spaces back. So there's going to be my y prime. Okay? Now I will rotate z 270 degrees. I will do this in purple. So z, if you notice, is 2 spaces away from the green vertical line. So I'm going to rotate this point about x 270 degrees. So it's 4 spaces away. So it's going to continue up to here. That's 90. There's 180. And one last turn will put us right here. There's our 270 turn. So there's our new point. And z was 2 spaces right behind it, which puts z 1, 2, z prime 2 spaces behind. Now we can connect these 3 dots, x prime, y prime, and z prime, to create our new triangle, x prime, y prime, z prime, and we can actually look at each coordinate to find the vertices, the coordinate pair. So x prime, remember, is equal to x. That is, so it's still located at 3, -1. Y prime is now located, it looks like, at x equals 0 and y equals -3. And z prime is now located at -1 for the x coordinate and +1 for the y coordinate.